The Future of Purpose-Built AI. Executive Summary. The AI industry moves away from general-purpose NVIDIA GPUs because they waste energy on non-AI features. The future belongs to specialized chips called ASICs, which major companies like Google, AWS, and Grok design for efficiency. These chips will handle specific tasks like language, image, and robotic analysis much faster. A mixture of experts, MOE, architecture, and software agents will coordinate these specialized chips. This shift ensures AI becomes significantly faster, cheaper, and more sustainable at global scale. Article: The modern world runs on artificial intelligence. AI models power everything from search engines to self-driving cars. These amazing technologies require immense computational power. Right now, general-purpose computer chips handle most of this heavy lifting. Companies mainly rely on graphics processing units, or GPUs, to run their largest models. A major shift is happening in the hardware industry. This change will make AI faster, cheaper, and much more energy efficient. The future of AI belongs to specialized, purpose-built chips. These chips perform specific tasks with extreme precision. The transition from flexible hardware to focused hardware drives the next great leap in AI. NVIDIA dominates the current market for AI hardware. Their powerful GPUs efficiently handle many tasks. Originally, engineers designed these chips for video games. They quickly realized GPUs could also handle the parallel math problems of AI training. However, these chips contain features specifically for rendering graphics. Such features include texture mapping units or shading cores. Language models do not need these extra functions. Running them on a general-purpose chip wastes significant time and electricity. This inefficiency becomes a huge problem at massive scale. Companies must serve billions of user requests every day. They seek better ways to lower their operational costs. They also want to reduce the total power consumption. This demand creates a pressing need for specialized hardware. Engineers started designing application-specific integrated circuits, ASICs. The name explains their exact function. ASICs execute only one task very well. They eliminate all unnecessary components for that job. This focused design offers tremendous advantages over GPUs. ASICs use less power for the same amount of computation. They also achieve much faster processing speeds, especially during inference. Inference means running a trained model to generate an answer. Training means teaching the model new things. The hardware industry now focuses intensely on inference chips. Companies like Google, AWS, and Grok already build these dedicated processors. Google created its Tensor Processing Unit, or TPU. AWS developed its own Inferentia and Trainium chips. Grok uses a unique chip architecture called a Language Processing Unit, or LPU. The LPU achieves incredible speed for large language models. These companies control their entire hardware and software stack. They optimize every part for AI performance. This strategy drastically lowers the cost of serving AI to customers. The rise of ASICs signals the end of general-purpose dominance. The future of AI involves many different types of models. Each model will perform a highly specialized function. Hardware designers will create dedicated chips for each specific model type. Language models, for example, will run on dedicated LPUs or TPUs. Another chip will handle complex image analysis tasks. A third ASIC will specialize in creating new images from text prompts. When you ask an "I like Gemini" for a picture, the system starts a separate program. That program most likely runs on a specific diffusion model. This model might already use a purpose-built chip for image generation. Other specialized chips will emerge quickly. We will see unique chips for sound analysis and audio generation. Robotic models need special chips to analyze real-time sensor data. These chips must process movement and balance instantly. World models which simulate physics and reality, will also need their own silicon. A single, enormous GPU cannot efficiently handle all these different needs. Specialized ASICs provide the necessary speed and power savings for all these diverse applications. This specialization drives the industry forward. This new system of specialized chips requires careful coordination. Imagine a central control system managing dozens of different processing units. A sophisticated software architecture makes this possible. This architecture is called the Mixture of Experts, or MOE. MOE models function like a team of specialists. The overall AI system contains multiple smaller submodels, or experts. Each expert specializes in a different type of task. The system routes the user's request to the appropriate expert. If you ask a coding question, the request goes to the coding expert. If you ask a history question, a different expert handles the request. This system significantly increases efficiency. Only a small fraction of the total model processes any given input. Agents and the MOE architecture synchronize these specialized chips. Agents act as autonomous computer programs. They break down complex user requests into smaller steps. An agent might receive the request, generate a picture of a cat, and write a poem about it. The agent immediately divides this job into two parts. First, the agent sends the image generation request to the Vision ASIC. Second, it sends the poem writing request to the language model ASIC. The agent then gathers the two results and combines them into one final answer. The MOE architecture provides the intelligence. The dedicated ASICs provide the raw speed. Agents provide the management layer that coordinates everything. This combination creates an incredibly powerful and efficient AI system. The shift to specialized hardware fundamentally changes how we build and operate AI. Companies will continue to invest heavily in these custom chips. The goal remains simple: deliver instant, affordable, and sustainable intelligence to everyone. The era of purpose-built hardware has finally arrived. Specialized inference boards for PCs. There are specialized boards you can plug into your PC that are primarily designed for AI inference, rather than general-purpose computing or graphics rendering. These are generally referred to as AI accelerators or neural processing units, NPUs. Dedicated inference boards, accelerators. These cards are built with hardware, often custom chips, specifically optimized for the mathematical operations common in running pre-trained machine learning models. Inference. Google Coral Edge TPU. This is one of the most well-known dedicated inference chips, and it's offered in formats that can be plugged into a PC. It comes as a USB accelerator, a mini PCIe accelerator, or an M.2 accelerator, which is a board that plugs into an M.2 slot typically used for SSDs. It's designed for low-power, high-efficiency inference at the edge, i.e., on a local device like a PC or embedded system. It runs models optimized for TensorFlow Lite. Older data center GPUs, high-end GPUs from companies like NVIDIA, such as the Tesla P4 or T4, were originally designed for data centers, where inference is a major workload. While they can also do training, their architecture, low-power envelope, for the P4/T4, and focus on INT8/low-precision operations make them excellent, power-efficient inference accelerators for a workstation environment. They typically connect via a standard PCIe slot. Multi-purpose boards optimized for AI. While not purely for inference, many modern GPUs are exceptionally good at it and are often the best choice for large or complex models. They use specialized cores to accelerate AI tasks. NVIDIA RTX/Quadro GPUs. The latest generations of NVIDIA's consumer, RTX, and professional, Quadro/RTX A series GPUs contain tensor cores that are highly optimized for matrix multiplication, which is the core of both AI training and inference. While you also get full graphics and general compute capability, for many AI users, these tensor cores are the primary reason for choosing these cards, and they offer a great balance of performance and flexibility for medium to large-scale inference tasks. The choice depends on your needs scenario, recommended board type, key features, small, fast, power-efficient edge models, Google Coral Edge TPU, very low power, small form factor, USB/M.2, cheap, mid to large-scale complex models, NVIDIA RTX/R TXA series GPUs, high performance, large VRAM, flexible for both training and inference, dedicated professional, high-density inference, NVIDIA Tesla P4/T4, used/server grade. Excellent efficiency, lower power draw than high-end RTX, purely compute/inference focused,